All right, today we're going to focus on understanding linear and compound inequalities. We're going to start with the most difficult and work backwards to the easier. If I ask you to tell me what is going on in -1 is less than or equal to x is less than or 2, you would say, oh, there's more than one thing going on. It's a compound inequality. You could rewrite it, as I would, as two inequalities. In this beginning one, I didn't give us any work to do. I just said x is going to be greater than -1 and x is going to be less than 2. That means there's two things that must happen for it to be true. The number has to be greater than -1 and less than 2. In a compound inequality, there are multiple signs that could happen. If it's less than or greater than, that means the endpoint is not included. We represent that as an open circle on the point. So in a case like this, when we graph actually the point -1, it will be graphed as an open circle on the point -1. Now, what if it were less than equal, greater than equal to? Then what would it graph as? Good, a closed circle on the given point. All right, let's start by graphing. Let's go to x is, and I usually, I'll be honest with you, use the symmetric property and flip this around because I like for the variable to be on the left. X, bless you, x is greater than -1. So when I make my number line, I don't need a great many numbers for this problem. I need x to be greater than -1. So I do not put it actually on the graph yet. I go right above it and I say, okay, that would be an open circle and greater than -1 is to the right. So that would give me what I wanted for this, only this half. Then I would go back and look and say, okay, this guy is x is less than 2. So that would be an open circle at 2, and this one would shade this way. Now the reason I put it above the line is because in an and compound inequality, what's the only part you want to keep? The part where they overlap. In this case, because of the way I made mine, it's the middle part of this one. It won't always be, but in this one, that's exactly what you keep, Tate. So I move my open circle to here and here, and then I only shade the part where they actually overlap, where it's both greater than -1 and less than 2. Interval notation would say that this would start at -1, -1 not included is what the parenthesis means, through 2 not included is what that parenthesis means. And I don't know that you've had any exposure whatsoever to interval notation yet. The parenthesis acts like an open circle. Later on, let's say you get a different example and its answer is -1 to 2. The bracket will represent a closed circle. Yes, Harrison?
So that one would have an open end closed.
Correct. On the left end, it would be a closed circle. On the right end, where 2 is, it'd be open. Perfect. And we will practice a whole bunch of interval notation because when you get to pre-cal, you are expected to understand and know how to write it as a graph, as an inequality answer, and has interval notation. Let's switch over. This was an and problem. This is just our quick introduction. This is an or problem. So there is a little more work to start out this problem. What is the first thing I have to do, Erica, on this left side? Perfect. Perfectly said. Get x by itself. So I'm going to subtract 1. That makes a 0 pair. X is less than -4. What must I do first over here, Riley, in? We made another 0 pair. X is greater than 2. I'm going to create a graph. At -4, I have an open circle I'm going to shade to the left. At x is greater than 2, I have an open circle again, and to the right.
Do you want us to do that, or do you want us to shade it?
I do not want the line shaded until you've tested it above it. Now, the next decision is, if this were an and problem, do you know what you would say right now? No real solution. Why? Because there was no overlap. Perfect. But because this is an or problem, that means it could be going this way or it could be going this way. That means you keep the entire solution. So you would move it to the number line. Put your open circles and your shading going both ways. Why are both of those open again? Remind me. Because it's not equal to. Good. It's just greater than on this end and just less than on this end. Do you agree that if you went this way, you would be heading to negative infinity? Okay. Do you agree that going this way, you would be headed to positive infinity? Do you ever get there? No. So when you represent this, reading left to right, you would have negative infinity, comma, negative 4. This one's open because it's not included, and you can never, ever get to negative 4. Like, you can get to negative 4.00000000001, but can you ever get to negative 4? No, it's not included. On this end, 2, reading left to right, we run into 2 next. 2 is not included. And can we ever officially get to positive infinity? No. So we have both of these answers. And I'm going to have to look up, I don't remember if we put the union side or the intersection sign there. So I need to look that up before tomorrow. So right now we're just going to use the word or, and tomorrow I'll tell you which one of those signs we're going to use. This makes it true, or this makes it true. Graphically, this makes it true, this makes it true. In inequality, this statement or this statement makes it true. Like I said, I was going to start with the 2 more difficult ones, the and the ors, and then I want to go back and quickly review one that is not a compound inequality. How many inequality signs are here?
One.
Just one. So there's one inequality sign. So it is not and, nor is it an or problem. When I start mixing all these on the same page, a common misconception for 18 years is students will try to make a 1 inequality sign problem into a 2. And that's just over time what I've seen. I'm not saying that you all would for sure do it, but I don't want you to make that mistake. How would you attack this first, Britta? So what would you do? Like, okay, so let's distribute the 2 then. 2x minus 8 is greater than 4x plus 6. What would you do next, Tate? Okay. So that would give us negative 2x on this side. What would you do next, Lakin? Add the 8, okay. Those make a 0 pair. Those make a 0 pair. And what would you do next, Harrison? When you get to this step, my expectation, when you divide or multiply by a negative, I expect you to circle the inequality. Why do you think I'm kind of force feeding you this little step? Most common error on the exam for this section is that when we multiply or divide by a negative, we forget to change the sense of the inequality. It is sensing greater than. What does it sense now? Less than. So x is less than -7. Open or close circle, Blake, at -7? Good, open. Says we're going less than, so we shade that. And changing it to interval notation simply means reading left to right that we'd run into negative infinity first. It always uses a parentheses if you are going to negative or positive infinity. -7 this time uses a parenthesis, but it could be a bracket. This particular one is not included, so we use the parenthesis. So this is inequality, this is graphing, and this is interval notation. 2 of the 3 are old news to you. But the interval notation, if you haven't been on academic team, is probably something a little bit new. Example 4. X plus 1 is less than -3, or x minus 2 is greater than or equal to 0. First decision, is there one inequality sign or 2? 2. What does the word or give away? It's an or problem. If you noticed over here, was there any words? Could this be an or problem? If it's a string inequality, it's always an and. Okay? It could have the word and, but if it's a string inequality all strung together like that, it's an and problem. If it has the word or, that's the only way you're going to get an or problem, or that I'm going to give you an or problem. What do you do first? Erica? Good. Why did I not circle the less than sign this time, Erica? Right, I do not have to switch when I subtract, only when I divide or multiply by a negative. Keandre, what would you do on the next one? Hunter, how would you graph the answer x is less than -4? Give me details. Okay, open circle at -4 and shade to the left. That was perfect. How would you graph the answer, Selena, to the x is greater than or equal to 2? Closer. Close circle, shade to the right. Now, I already knew it was an or. What should I have done? I should have done this just to make sure that I took the time to double check that whether it was or or and. The infinities always use parentheses. The -4 was not included, so it has a parenthesis. The 2 was included in the answer, so it has a bracket. Here's the inequality answer, the graph answer, and the interval notation answer. Let's do one more. -4 is less than 6x minus 10 is less than or equal to 14. How many inequalities are there, Ashby? 2. Why is that important? What's our next decision, Rob, with this? Whether it's and or. So what do we think it is, Chloe? And. Good. This is where I want you to drop your pencil or whatever so you can totally focus just for a second. There is a common misconception that you split the middle piece, that you say -4 is less than 6x and -10 is less than or equal to 14. Does anybody know why that's not correct? Go ahead, Hunter. I made your name Hunter, sorry. Say it again. Doesn't even have variable, does it? This entire quantity is shared by both inequalities. So when you write them out the long way, -4 is less than 6x minus 10. Make sure you write your word and 6x minus 10 is less than or equal to 14. So that center segment of the inequality is shared by both the left end and the right end. Emily, what would you do next? I think I would too. I think I would add 10 and get it over here. Oh, it's fine. So we should have 6 is less than 6x because that made a 0 pair. What would you do next, Spinda? Good. Why did I not circle my inequality there? Right. And I think I would use the symmetric property and flip that around. Ashby, how would you attack this guy? Perfect. That made a 0 pair. 6x is less than or equal to 24. Savannah, what would you do now? Good. And Rachel, what will my final answer for this right side be? Perfect. Divide or multiply by negative. Perfect. And we have our word and here, so this is our answer in inequality form. So now x is greater than or equal to 1. So I'm putting an open circle above 1 and going greater than. I'm putting a closed circle above 4, and it says x is less than or equal to 4, so it's going this way. So how do I decide on my final answer here? Hannah R. Only the part where they intersect. And because of the way I drew my graph, do you notice that it's consistently in the middle, like that this is really, though, not symmetric, like I didn't draw them symmetric. Okay. Open on this end, closed on this end, shaded in the middle. Hannah D, what would my interval notation look like this time? Perfect. That's our inequality notation, our graphing answer notation, and our interval notation. What are the 3 things that you'll have to decide at the beginning of each question? First of all, how many inequalities are there? Is it a single answer? Is it going to be compound? Second, when I graph it, will the endpoints be open or closed? And what's the third thing? Am I shading which way? Left or right? Okay. And when I do that, do I count the overlap or do I count everything because it's an or problem? All right. So 3 major things to be deciding.